Hello class, today's lesson is on multiplying rational expressions.
Today we're going to talk about multiplying rational expressions. Since a rational expression is really just a fraction, let's look and review what we would do to multiply regular fractions. So let's look at regular fractions first. Suppose we have 3/4 times 6/15. One way is just to multiply, which we always multiply numerator times numerator over denominator times denominator, and we end up with 18/60. We always want to reduce to lowest terms, so if we divide both our numerator and denominator by 6, we end up with 3/10. Another way to approach this is to cancel out common factors. So to cancel out common factors, we can cancel out diagonally a fraction's numerator with another fraction's denominator, or we can cancel out vertically a fraction's numerator with its own denominator. If we look between the 3 and the 6, and the order in which we cancel out common factors does not matter. So we can cancel between the 6 and the 15, or the 3 and the 15. It doesn't matter. If I cancel between the 3 and the 15, I see I can divide 3 into 3 once. 3 will go into 15 5 times. And then between the 4 and the 6, I have a factor of 2 in common. 2 will go into 6 3 times, 2 will go into 4 2 times. And I still, remember, I multiply numerator times numerator over denominator times denominator. Don't cross multiply. You can only cross multiply across an equal symbol, not a multiplication symbol. And you get 3/10. This is the method that we're going to use for simplifying and multiplying rational expressions. So let's look at 4x cubed over 3x times 14 over x. If we look at the numerators, we'll see that there's not the numerators, the coefficients and the constants. There's nothing we can cancel between the 3 and the 4, nor the 3 and the 14. You never cancel horizontally. So there's nothing, you would not try to cancel between the 4 and the 14. Now let's look at the x's. Order does not matter in which you cancel. X will go into x cubed, x squared times. Remember, when you're canceling involving exponents, you're really subtracting the exponents. And then I can cancel this way. X will go into x once, x will go into x squared, x times. Now I'm ready to multiply. 4 times 14 is 56 times x over 3 times 1 is 3. And I get 56x over 3. Let's look at this one. A squared minus 9 over a squared times a squared minus 3a over a squared plus a minus 12. We want to factor the numerator and denominator of each rational expression completely. The a squared minus 9 factors as the difference of two squares. It factors into a plus 3 times a minus 3. There's nothing we can do with the a squared times this numerator, a squared minus 3a. We can factor out a GCF of a, so we're left with a minus 3 over. Now this one, this trinomial, let's look at it. A squared minus a minus 12, a squared plus a minus 12, So we're looking for two numbers with a product of the last term and with a sum of the middle term, which is 1. So if we look closely, those two numbers are going to be 4 and -3. That's because 4 and -3 times -3 is -12, and 4 plus -3 is +1. So that factors into a plus 4 times a minus 3. Now we're ready to cancel out common factors. Remember, we can cancel out diagonally or vertically. So I can cancel this a minus 3 with this a minus 3, or this a minus 3 with this one. It doesn't matter. Suppose I cancel this way. And look at the a's. I can cancel between the a's. A will go into a once. A will go into a squared a times. And I think that is much as I can cancel, so I'm ready to multiply. I'm left with a plus 3 times a minus 3 in the numerator, and in the denominator I'm left with a times a plus 4. This is your answer, and this is an acceptable form to leave it in to make sure you have no common factors, so you don't have to multiply that out. Okay? Let's look at this one. We have 5a squared minus 180 over 10a squared minus 10 times 20a plus 20 over 2a minus 12. So we want to multiply these two rational expressions. The first thing we want to do is to factor each numerator and denominator completely. So let's look at the 5a squared minus 180. I can factor out a GCF, or a greatest common factor, of 5. And I'm left with a squared minus 36 in the numerator. 10a squared minus 10, that denominator, I can factor out a GCF of 10, and I'm left with a squared minus 1 times this numerator, 20a plus 20, I can factor out a GCF of 20, and we're left with a plus 1. And then in the denominator, 2a minus 12, we'll factor out a GCF of 2, and we're left with a minus 6. Now I want to make sure each numerator and denominator is factored completely before I start canceling common factors. So notice the a squared minus 36 is not factored completely. That is the difference of two squares, so that factors into a plus 6 times a minus 6. And also in the denominator, the a squared minus 1 is the difference of two squares, so that factors into a plus 1 times a minus 1. And this other rational expression, that is factored completely. So now I'm ready to cancel out common factors. I'm sorry, that should be a 2. Okay? Now let's look at the coefficients first. Between the 5 and the 10, I can cancel a factor of 5. 5 will go into 5 one time. 5 will go into 10 two times. And between the 2 and the 20, I can cancel a factor of 2. 2 will go into 2 once. 2 will go into 20 10 times. And between the 2 and the 10, I can cancel a factor of 2. 2 will go into 2 once. 2 will go into 10 5 times. The order in which you cancel does not matter, just as long as you do it correctly. So now I've done everything with my coefficients. Let's look at the variable expressions. I can cancel the a minus 6's and the a plus 1's. So I'm left, remember I'm multiplying numerator times numerator. The only thing I have in this numerator is 5 times a plus 6. Usually we write the 5 first. Over in the denominator, I'm only left with a minus 1. So this is the product of these two rational expressions. Remember, you cannot cancel the a's because this a is hooked with this 6 and this a is hooked with this -1, so you would have to cancel the entire thing.
Remember, in order to learn math, you've got to do math. You got this. Class dismissed.